Hello, this is Scholar Strife doing some math. Today in Algebra 2, we're going to solve logarithmic functions. So here we go. Exponentiate. So exponentiate is to rewrite both sides of an equation as exponents for the same base. And we'll look at that in a bit. Property of equality for logarithmic equations. If x equals y, then, if x is y, log base b of x equals log base b of y. And vice versa. If log base b of x equals log base b of y, then x equals y. Where x, y, and b are positive, and b cannot equal 1. So, for example, if we have log base 2 of x equals log base 2 of 7, then x equals 7. And vice versa, if x equals 7, then log base 2 of x equals log base 2 of 7. Alright, so if you have logs on both sides of the equation, if they have the same base, then you can cancel the logs and set the expressions equal and solve the equations. Remember to check for extraneous solutions. So, let's see. So we have this problem here. Log base 5 of that mess equals log base 5 of that mess. Now what it says is we can just cancel those, and we're left with the insides. Okay. So this looks like a quadratic equation. So I'm going to subtract, or move everything from the right side to the left side. So I have 2x squared. 7x plus 12x is 19x. Minus 10 is equal to 0. And this will this one will become if we use our old quadratic techniques. So 19x is the same thing as plus 20x minus 1x minus 10. And then we can group. So I'm going to group here, and here, and then here, and here. So I'm going to get, I'll factor out a 2x and get x plus 10 here, minus, point out minus 1, x plus 10 here. So I'll get a, this will factor down to 2x minus 1 times x plus 10 equals 0. So x equals 1/2, or x equals negative 10. And you want to plug these back into the equations and make sure this works, because you can't take the log of everything. You can't take the log of a negative number. So if I plug in 1/2 into these, the left side is okay. The right side is 1/2 of negative 12 is negative 6 plus 10 is still positive, so we're good. So this one works. If I plug in negative 10 to both these equations, I'll get 2 times 100 plus negative 70, so that's good. And then negative 12 times negative 10 is positive, so yes, those work. Just want to make sure that the equation is still able to happen. Alright, number 11, natural log of something equals natural log of something. We can cancel out the natural logs, and we're left with 7x minus 4 equals 2x plus 11. And then we have 5x equals 15. Moving the 2x to the left and the minus 4 to the right. So x equals 3. We plug this back in. 7 times 3 is 21 minus 4, that's positive. And then 7 times 2 is 14, plus 11 is 25. So, 2 times 3 is 6, sorry. 2 times 3 is 6, plus 11 is 17. There we go. So we got natural log of 17 equals natural log of 17. Yes, this works. What happens if there's only a log on one side? You condense the logarithm as much as you can. Get the logarithm by itself. Rewrite the equation in exponential form. Solve the equation. And then I'm going to check for extraneous solutions. So number 12. Okay. So we have log on one side. And what we're going to do is the opposite of log, or the inverse, is to exponentiate. So I'm going to put everything into the exponent spot with a base of 2. So this is 2 to the log base 2 of x minus 6 equals 2 to the 5th. Okay. So what I'm doing is exponentiating. Alright. 2 to the log base 2 cancels out, and you're left with x minus 6 equals 2 to the 5th. 2 to the 5th is 32. So we're left with x equals 38. And if we plug it back in, we'll get 38 minus 6, which is 32. Log base 2 to the 5th does indeed equal 32. So this works out. Alright, 13. Okay, so first we have to get the log by itself. So I'm going to get rid of this this positive 7 by subtracting 7 over. And then I have minus log base 3 of 8x equals negative 5. And then get rid of that negative sign, so make everything positive, dividing by negative 1. Okay. So log base 3, I'm going to exponentiate. I like to call it, I'm going to base 3 both sides. You can either say exponentiate both sides or base 3 both sides, how I like to do it. So this is going to be, if I move it up here, 3 to the log base 3 of 8x equals 3 to the 5th. So 3 to the log base 3 cancels out, and we're left with 8x equals 3 to the 5th, which is 243. And my answer is x equals 243 divided by 8. Alright, let's do another one. 14. ln of 3x minus ln of 2 equals 4. So remember, we need to condense these. The minus sign means ln of 3x divided by 2 equals 4. So we're going to exponentiate both sides. Remember, natural log is base e. So I'm going to e both sides. So let's see how that looks. E to the ln of 3x over 2 equals e to the 4th. So I'll have 3x over 2 is about, because you have to punch this in your calculator, 54.6. Multiply by 2, divide by 3, and we'll get x is about 36.4. And basically, when we're checking these, we just got to make sure that either it matches up or we have a positive value in our log or natural log, because we cannot take log or natural log of negative numbers, like square roots. Number 15. Log of 5x plus log of x minus 1. So this is what's going to happen. We're going to combine the logs. When we have a plus sign, we multiply the insides together. So 5x times x minus 1, and then equals 2. So I'll simplify a little bit. Log of 5x squared, that's a minus, so minus 5x equals 2. Okay, log without a base is, remember, log base 10. So I'm going to exponentiate both sides. 10 to the log and 10 to the 2. So 10 to the log cancels out, and I'm left with 5x squared minus 5x equals 100. Okay, I'm going to subtract 100 over, and then I'm going to factor. So I'm going to take out a 5 at first. So I have 5 times x squared minus x minus 20. And this will factor to 5, x minus 5, x plus 4. So x equals 5, x equals negative 4. If I plug 5 in the above equation, it works. We have log of a positive number. But if I plug in negative 4, I got log of negative 4 minus 1, so log of negative 5. This is extraneous. So the only answer you have is x equals 5. All right. Oh, I need to... Oh, never mind. Let's continue. So, exponents with same base. Basically, you set exponents equal. And then you solve. So if I have 7 to the 3x plus 4 equals 49 to the 2x plus 1. Remember, 49 to the 2x plus 1 is the same thing as 7 squared to the 2x plus 1. So those exponents get multiplied. So 3x plus 4 is equal to 4x plus 2. That's me distributing this 2 to those 2. Okay. If we have exponents with different base, we take the log or natural log on each side, and then use change of base. So if I have 8 to the x equals 20, then I'm just going to use log base 8 to both sides. Okay. So these will cancel, and you're left with x equals log base 8 of 20. And if you wanted to use your calculator, you would do log of 20 divided by log of 8. And then if there's log on both sides, cancel the logs. Set the expressions equal, and then solve. So if we had log base 5 of 4x plus 9 equals log base 5 of 6x, was 4x plus 9, then we would say 4x plus 9 equals 6x, and then we would solve from there. Logs on one side, condense log plus get log alone, get log alone, and then rewrite as exponent. Rewrite as exponent. So if we had log base 2 of x minus 4 equals 6, so we would get the log alone, and then we'd exponentiate both sides, or base 2 both sides. So we have 2 to the log base 2 of x minus 4 equals 2 to the 6. So you would get x minus 4, because those cancels out, equals 2 to the 6, which is 64. And then solve from there. Use the Richter scale formula. So find the intensity I. So there's our Richter scale formula there. Find the intensity I as compared with a reference intensity, ISO, or initial intensity, of the 1906 San Francisco earthquake if it had a Richter number of 8.25. So our Richter scale equals log of I over ice of O. So we have 8.25. Our number there, Richter scale number, equals log. Trying to find how intense this is, where I sub O is 10 to the negative 3. Okay. So to get I by itself, I'm going to exponentiate both sides. So remember, log is just log base 10. So I'm doing base 10 to both sides. So I'll have 10 to the 8.25 equals I over 10 to the negative 3. So we're going to get 177,827,941 equals I over 0.001, multiply it by that number, and our intensity is 827,941. All right. Oops. Okay, now we have Newton's laws of cooling, and then there's our Richter scale formula again. So our Richter scale's formula is an example of a logarithmic equation, and our Newton's law of cooling is an exponential. Newton's law of cooling describes the cooling of a warm object to a cooler temperature of the environment, or vice versa. Richter scale is the magnitude of an earthquake, measured as a Richter number. So, property of equality for exponential equations. So, if x equals y, then b to the x equals b to the y. So that means if 3 to the x equals 3 to the 5, then x equals 5. B must be positive. And b cannot equal 1. And this actually works vice versa. If x equals 5, then 3 to the x equals 3 to the 5th. If possible, rewrite the bases so that they are the same. Alright, so we have 9 to the 2x equals 27 to the x minus 1. So let's try to rewrite the bases so that they're the same. 9 as a base can also be written as 3 squared. So this is 3 squared to the 2x equals 3 cubed, that's 27, to the x minus 1. Okay, exponent to the exponent means we multiply them. So 3 times the 3 to the 4x equals 3 to the 3x minus 3. So I'll have 4x equals 3x minus 3. Because they are the same base, it means we can write them equal to each other. So when I subtract 3x over, I'll get x equals negative 3. Okay, so let's do another one. So this is 3 to the first, and I'm going to rewrite 1/3 as the same thing as, so I have 3 to the x equals 3 to the negative first to the x plus 3. So I'm going to distribute that negative 1 and get 3 to the x equals 3 to the negative x minus 3. I can drop the bases because they're the same, so x equals negative x minus 3. So 2x equals negative 3, so x equals negative 3 halves. Okay. 81 is the same thing as 9 squared, or 3 to the 4th. So this is 3 to the 4th to the 3 minus x equals 3 to the negative 1 to the 5x minus 6. Okay, 4 times 3 is 12 minus 4x. So I already skipped the part where I dropped the bases. Negative 1 times 5x is negative 5x plus 6. Okay. I'm going to move the negative 5x over to the left side and the 12 to the right side. So I'm going to add 5x and subtract 12. So I'll get x equals negative 6. Alright, if the bases cannot be made the same, then take a log of both sides. Use a number for the base that is equal to the value with variable exponent. And then use change of base. To solve. Alright, so 2 to the x equals 5. So I'm going to log both sides. Base 2. So I'm going to log base 2 both sides. And I'm going to get log base 2 of 2 to the x equals log base 2 of 5. So log base 2 of 2 cancels, and we're left with x equals log of 5, if I'm using change of base, equals log of 2. And that's something we can put in our calculator, which should give us around 2.322. Okay. 7 to the 9x equals 15. So we cannot make our bases the same. So we're going to take log base 7 of both sides. So log base 7 of 7 to the 9x equals log base 7 of 15. So this will be 9x equals log of 15 over log of 7. Okay, and then 9x is about 1.392. And then you would divide both sides by 9 to get your answer. Okay, number 6. We're going to get e, try to get the e component by itself. So I'm going to add 7 over, and I have 4e to the negative 0.3x equals 20. And then I'm going to divide both sides by 4. So I have e to the negative 0.3x equals 5. The opposite of e is to take the natural log of both sides. So I'll have negative 0.3x equals natural log of 5. You can put that in your calculator, divide by negative 0.3, and you'll get your answer. Word problems. So you deposit $800 into an account. If you remember, this is our principal. That pays 0.5% annual interest, so 0.005 is our R value. Compounded monthly, so N equals 12. How long will it take for the amount to grow to 1,000 if you do not deposit any more money? So this time they give us our A value. So remember this equation here, A equals P times 1 plus R over N to the NT. Normally they give us time, so we try to find the final amount. But this time we want to know how long it'll take us to grow to $1,000 if we don't deposit any more money and we just deposit an initial amount of $800 at 5% interest. So A is 1,000 equals our initial amount 800 times 1 plus 0.005 divided by 12 to the 12t. Okay, I'm going to divide both sides by 800, and that'll give me 1.25 equals, the inside is going to be 1.00417 to the 12t. Okay, and this is where it gets a little silly. So we're going to take the log of both sides to get 12t down there. And I'm going to use log base 1.000417 of 1.25 equals log base of this will cancel out, and we're left with 12t. So we're going to use the change of base formula to solve the right. So that's going to be log of 1.25 divided by log of 1.000417. Okay, and then once we get that answer, so 12t equals about 535.228. Divide that by 12, and t will be about 44.6 years. That's only if you have a 0.5% annual interest. Newton's law of cooling. Here's an example of this. So hot chocolate that has been heated to 90 degrees Celsius is poured into a mug and placed on a table in a room with a temperature of 20 degrees Celsius. If R equals 0.145, and then time t is measured in minutes, how long will it take for the hot chocolate to cool to a temperature of 30 degrees Celsius? Okay, so t, the temperature at the object at time t, so that's 30 degrees Celsius. The initial temperature of the object is 90 degrees Celsius. The constant temperature of the environment is 22. So temperature of the room, 20 degrees Celsius. Rate of cooling, they gave us to be 0.145. And we're looking for time. So 30 equals 90 minus 20 to the e to the negative 0.145t plus 20. Okay, so I'm going to get rid of this plus 20 by moving it over. So I'll get 10 equals 90 minus 20 is 70 e to the negative 0.145t. Okay, divide by 70 and I'll get 1 over 7 equals e to the negative 0.145t. To get rid of e, we're going to take the natural log of both sides. So natural log of 1 over 7 equals natural log of e cancels, so negative 0.145t. This becomes 1.950 equals negative 0.145t. Divide, and we'll get t is about 13.42 minutes. Our time t is measured in minutes. Yep. Okay. Let's do another one. A detective is called to the scene of a crime where a dead body has just been found. So we're doing some CSI stuff. She arrives on the scene at 10:23 p.m. Immediately the temperature of the body is taken and is found to be 80 degrees Fahrenheit. So, let's write down all this stuff. So T, so we found the body to be 80 degrees. The initial temperature of the body we assumed to be 98.6 before it died. The room temperature is 68 degrees. R, .134, and then we're looking for, what are we looking for? What time did our victim die? So we're looking for time in this case. Okay. So we have the formula T equals T initial temperature minus room temperature E to the negative RT plus room temperature. So 80 degrees equals 98.6 minus 68 e to the negative 0.134 t plus 68. So we're going to subtract 68 from both sides and get 12 equals 30.6 degrees e to the negative 0.134 t. And we divide both sides by 30.6 and we'll get 0.3922 equals e to the negative 0.134 t. Take the natural log of both sides. So move it up here. 0.3922 equals negative 0.134 t. So this will become negative 0.936 is about negative 0.34 t. Divide, and we'll get t is about 7 hours. Now in the previous problem I had minutes. Why is it hours in this one? Because, so about 7 hours is because they told us in the hot chocolate problem that it was measured in minutes versus this one was per hour. So the rate of cooling is per hour in this case. So T is about 7 hours. So since the detective took the time at 10:23 p.m., so we just subtract 7 hours. So the person died around 3 o'clock p.m., 3:23 p.m. Alright, hopefully this helps you out. Have a good day.